Good morning, students. Welcome back to 10th class physical science class. In last video, we concluded up to eye defect called myopia. Now we will continue from hypermetropia. As you know well, whenever if the focal length of the eye lenses does not lies between 2.5 to 2.27 centimeters, in such conditions the people may get the eye defects. So for example, if you take myopia, it is because if the maximum focal length of eye lens is less than 2.5 centimeters, in such condition, the image forms in front of retina. So how can we correct this myopia? What type of lens we have to be used? In order to correct myopia, we have to use double concave lens. Why we should use only double concave lens, not double convex? For that, we have to calculate the focal length of the given lens. If you may get negative, then definitely we have to use a concave lens because the focal length of the double concave lens is negative. So by using this double concave lens, what we are doing here, simply we are bringing the object at M. M is nothing but 4 point and between M and L, so as to get image on retina. So what is use of this lens? For example, if an object is present beyond M, in such conditions, the people, those who are myopia, they are unable to see. So by using this double concave lens, we are going to bring the object at M or between M and L, and that image again becomes object for the eye lens. The final image is forms on retina. Is it clear? So that is about myopia. So next, coming to the hypermetropia. What is hypermetropia? Some people, they can see far object, but they cannot see near object. Such kind of eye defect, what we call hypermetropia. They can see far object, but they cannot see near objects. Generally, a few students, they can sit at last bench because they are able to see far object, but they cannot see near objects. So such kind of eye defect, what we call hypermetropia. What is the reason for getting this hypermetropia? If the minimum focal length of the eye lens is greater than 2.27 centimeters, in such conditions, the rays which are coming from the object of refraction, they are converged after retina, not before retina, not except on retina, after retina. So how can we correct this eye defect? What type of lens we have to be used? Before going to seeing that, see what is here. We will see for a near point. What on a near point? What is meant by near point? For example, I am suffering with hypermetropia. See what is meant by near point? The point of minimum distance of which a eye lens can form image on retina. For example, I am suffering with hypermetropia. I can see the object which is placed at near point called H. Here, in case of my hypermetropia, we have near point called H. See, this is L, least distance of distinct vision, and this is H, near point. In case if the object is present between H and L, then such condition the image forms beyond retina. See, if I place object exact at H, yes, image forms exact on retina. See, for example, I am suffering with hypermetropia. My near point is 100 centimeters. Now, can I see the object which is placed at 100 centimeters? Yes. Now, if the object is placed at a distance of 75 centimeters in front of my eyes, in such conditions, then can I see the object? No, because I can see the object which is placed at H or beyond H. I cannot see the object which is placed between H and L because my near point is 100 centimeters. For example, if an object is placed at a distance of 110 centimeters, yes, in such conditions, I can able to see the object which is present beyond H. So the people, those who are suffering with hypermetropia, they can able to see the object which is present at H or beyond H. They are unable to see the object which is present between H and L. H and L. How can we correct this hypermetropia. In order to rectify this hypermetropia, we are going to use a double convex lens. Sir, why should we use only double convex lens? Again, for that, we have to calculate the focal length of the given lens by using lens formula 1 by f is equal to 1 by v minus 1 by u. In case if you make it the focal length of the given lens is positive, then we should use a double convex lens to rectify a defect called hypermetropia. Is it clear? The next one is presbyopia. Before going to see the presbyopia, what is purpose of using this double convex lens to rectify a defect called hypermetropia? What we are going to do here? Simply we are going to bring the object beyond H or H, which is present between H and L. There we may get the image, and that image again becomes object for the eye lens. The final image is formed on retina. Is it clear? The next eye defect is presbyopia. What is presbyopia? Generally, some people they cannot see near object as well as far object comfortably and distinctly. The reason behind is the weakening of ciliary muscles and the diminishing flexibility of eye lens. Because of these two reasons, some people generally they cannot see near object as well as far object well. We could see this type of eye defects generally those who are above 60 years. Because of aging, this type of eye defect will be comes for the people. Is it clear? Then how can we rectify these eye defects? By using both double concave and double convex, simply bifocal lens. By using bifocal lens, we can rectify eye defect called presbyopia. Sir, here we have only these three eye defects? No, we have a few more like cataract and astigmatism. Cataract is nothing but the layer which is formed on our retina. So by doing laser operation, we can correct it. And astigmatism is because of the eyeball which is come out of most of the part is present outside. So by using cylindrical lenses, we can rectify a defect called astigmatism. Is it clear? Fine. So presbyopia we can rectify by using double focal lens. Since it contains both double concave and double convex lens. The upper portion is concave and the lower portion is convex. Is it clear? The next one is how the doctors can, whenever if you go to the optical shop, then the doctor will test our eyes and they will write some prescription after testing. What is there in that prescription? Sometimes you may heard this word, my sight is increased, my sight is decreased. What does it means? So next we are going to, in order to design lenses for a particular eye defect, they are going to be calculate the focal length and power of the lens. Focal length and power of the lens. What is meant by power of the lens? The divergence or convergence of a given lens, which are generally seems to be expressed in terms of the power of the lens. Otherwise, simple definition is the reciprocal of focal length is nothing but the power of the lens. The reciprocal of focal length of the given lens is nothing but power of the lens. Is it clear? The unit is diopter. The unit of power of the lens is diopter, and we can represent with capital D. So generally, the doctors are advised to use 2D lenses. What is the reason behind that? Because of its focal length. What is the focal length of the 2D lenses? In order to find that, we should calculate the focal length of the given lens by using P is equals to 1 by F. P is equals to 1 by F. We can write P is equal to 1 by F in meters, or P is equals to 100 by F in terms of centimeters. So here, then what about F? F is equal to 100 by P. Then what is P here? 2D. Then 100 by 2 is nothing but 50 centimeters. So that is the reason why the doctors are advised to use 2D lenses only, because of its focal length. Is it clear? The next thing is we are going to see about the prism. What is prism? A prism is have a look at here. Prism is a transparent medium which is separating from the surrounding by at least two lateral plane surfaces. At least two lateral plane surfaces, and these two lateral plane surfaces are inclined to each other. Clear? So basically the prism has two triangular bases and three rectangular lateral surfaces. These three rectangular lateral surfaces are always inclined to each other, and the angle between any two lateral surfaces will give the angle of the prism. Angle of the prism. Once look at here, this is prism having vortices P, Q, R. So whenever ray of light is falls on any one of the surface, the refraction takes place and it can be emerges from the second surface of the prism. The angle between incident ray and emergent ray will use angle of deviation. Here, the most important thing is here we are going to find the refractive index of the prism as n is equals to sine of a plus d by 2 by sine a by 2. Sine of a plus d by 2 by sine a by 2. Here a is angle of the prism, d is angle of deviation, angle of minimum deviation, and n is the refractive index of the prism. In order to find this, we have to conduct an activity. Now here we will see only the refractive index of the prism as n is equal to sine of a plus d by 2 by sine a by 2. In exam, sometimes they may ask question or sometimes they may ask problem based on this refractive index of a prism. Remember, for a particular refractive index of the prism, the angle of minimum, the prism has only one angle of minimum deviation. Only one angle of minimum deviation, but whenever you pass a white light to the prism, then we may observe 7 different colors. What is the reason? About that thing we will discuss at the time of dispersion of light. Okay. So anyway, here in exam they may ask question like this. A prism produce angle of 60 degrees. An angle of prism is 60 degrees which produce the angle of minimum deviation as 60 degrees. Then what is its refractive index? What is its refractive index? In order to find the refractive index of the given prism, we should use n is equal to sine of a plus d by 2 by sine a by 2. Sine a by 2. If you can substitute the value of a is here 60 degrees, d 30 degrees. So then if you can substitute these two values, then you can get the refractive index of the given prism. Is it clear? So at the same time, by drawing the angle of incidence value and angle of deviation on graph, so we could find the angle of minimum deviation. At the same time, we could find the relation between angle of prism, angle of deviation, angle of incidence, and angle of emergence also. We could find it as a plus d is equals to I1 plus I2. A plus d is equals to I1 plus I2. Is it clear? Is it clear? The next thing is here we are going to discuss about the dispersion of light. See, whenever if you pass a white light to the prism, it can be split into 7 different colors called dispersion of light. We can see 7 different colors like VIBGY are violet, blue, violet, indigo, blue, green, yellow, orange, red. Likewise, we can see 7 different colors. Whenever if you pass a white light to the prism, it can be split into 7 different colors. This is what we call a dispersion of light. The natural phenomena for this dispersion of light is formation of rainbow. The phenomena behind the formation of rainbow is the dispersion of light. The phenomena behind the formation of rainbow is dispersion of light. See, just now we discussed for a particular refractive index value of prism, it has only one angle of minimum deviation. No? Then, whenever if you pass a white light to this prism, why does it will be split into 7 different colors? Because different colors have different refractive index values, different wavelength, and different speed also. So because of that reason, whenever if you pass a white light to the prism, it will be split into 7 different colors, because each color has different refractive index, different wavelength, and different speed. Already in previous video, we discussed why we should use only red or orange, yellow or green colors in signals, because of their wavelength and speed. For example, if you take a red color, it has more wavelength and less refractive index value. Because of that reason, it can be travel a longer distance. The speed of light is more for wavelength. So that is the reason why we should use only the red color in signals. After that, you may have orange, then you may have yellow. So that is the reason of using these colors in signals, because they have the deviation is less, more refractive index, more refractive index. See, if you see the violet color, it has more refractive index, less wavelength, more deviation. If you take red color, it has more wavelength, less refractive index, less deviation. So the deviation is depends on especially the refractive index of the color. So that is the reason why the white light is split into 7 different colors whenever you pass through the prism, because each color has their own refractive index values and wavelength. Is it clear? The next one is, you may get one doubt, sir, if I pass only red color, then how many colors I get here? Only one color, because each color has constant frequency. The number of waves which are entering from one end of the one surface of the prism is equals to the number of waves which are leaving from the second surface. See, whenever if you pass any one of the color, single color instead of white color, then it can retain the same color, because the frequency is always constant. Only the change is wavelength and speed of light. From V is equal to F lambda. F is constant. If wavelength is increases, the speed of light also increases. If wavelength is decreases, the speed of light also decreases. That is the reason why they can get the same color. Is it clear? Next one is, sir, where we can see the phenomena of this dispersion of light, formation of rainbow. Generally, after a small rain shower, we can observe a beautiful phenomena of dispersion of light called rainbow. It could be because of dispersion of light. We can observe the 7 different colors like as a arc. Yes or no? Is it clear? The next one is, what is the reason for the formation of rainbow? See, because of the sunlight dispersed by the number of tiny water droplets. See, if we will see here, in case of a single drop, this is a water drop, then the number of rays will be falls on this. From this, here in the formation of rainbow, we could see 3 different types of phenomena, like total internal reflection, next reflection, then we can see dispersion of light. Is it clear? See, all the time we cannot see the brightest of rainbow. In case if the angle between incoming and outgoing ray is 42 degrees, in such conditions we may see red color. If it is 40 degrees, then we can see violet color. If our eyes lies between these 2 angles, 40 to 42 degrees, then we can see the remaining colors also. Is it clear? See, generally the rainbow which is appearing to us, it is not an arc. It is like as a 3-dimensional cone. We can see the tip of this rainbow only. Actually, the shape of the rainbow is not an arc. It is a 3-dimensional cone. The tip is entering our eyes. See, all the time only one color is entering into our eyes. The remaining colors maybe goes to below the eyes or top of the eyes. Every time from every drop, only one color will be reaches to our eyes. Is it clear? The next most important phenomena is scattering of light. What is mean by scattering of light? See, whenever you know very well, our atmosphere is contains a number of molecules and atoms like N2O2, H2O, O2, like this. Yes or no? So whenever if the size of atom is comparable with the wavelength of light which is falls on it, then this atom is absorbs the light which is falls on it and vibrates, again re-emits this energy into all directions with different intensity of light. Such a kind of phenomena what we call scattering of light. What we call scattering of light. The atoms or the molecules which are responsible for the scattering of light are called scattering centers. You can see the maximum scattering of light at an angle of 90 degrees. You may ask one doubt, sir, why does the sky will be blue in color on bright day? The reason is, just now we discussed, our atmosphere is contains number of molecules called N2O2, H2O, like this. The reason behind for the blue color of the sky is the presence of N2 and O2 molecule. The wavelength of this molecule is comparable with the wavelength of blue color. So these N2 and O2 act as a scattering center for the blue color. Then why does sometimes the sky will be appears white in color? Because of the abundant presence of water molecules. Abundant presence of water molecules. See, in case of hot summer days, then the presence of water molecule is atmosphere is more. So this water molecules act as a scattering centers. So because of that reason, the sky will be appears almost all the wavelength of this is almost all equal to all the colors. So it will appears white in color. The most important one is why does the sun will be appears during sunrise and sunset? Because of the scattering of light. Light has to travel longer distance. So except red color, remaining all colors will be scattered into atmosphere. So the sun will be appears traditional color during sunrise and sunset. So if you want to get more information, details about this lesson, you please watch this video again and again. Thank you for learning.